two nodes. So if you want to get that out, that's what's next. So, oh, I mentioned it once. No. HO is the no. HA is the alternative. Yeah, we're trying to prove the alternative true. Done nothing. Maybe that'll become like a worldwide sensation. Like pickleball blew up, maybe we can make garbage ball blow up. Do people want more time, or am I good to go a little more? So most of these you'll notice are like not math. So yeah, usually students in this class struggle more with the vocab and concept of actual math. That's what Saturday review. Because you thought this was a math class. You got tricked. No. You Boston today? That's pretty good. When's regionals? That's just reverse. Use. I'm gonna do this for my. So what is sampling variability? That is the idea that every sample is different. Your sample is not special. So, you know, my sample doesn't mean anything more than your sample, doesn't mean anything more than her sample, and they all might be different because you're sampling different people. Probability that a z-score is lower than negative 2.1, you can go negative, normal CDF, negative 999 to negative 2.1. You don't have to tell the calculator the mean and the standard deviation because the only point of that is to find the z-score, and we have the z-score. I got 0.07186. P is a parameter from the population. P hat is a statistic from the sample. I bolded one. I hope that's okay. Instead of circle. If the p-value is less than alpha, we reject. HO is also known as the null hypothesis. HA is also the alternative hypothesis. And then 7 is false. If I wanted to fix it, I would say we reject it or we fail to reject it. So now it's true. I don't know if that's kind of weird how I put those answers up. Any questions on any of those? Alright, grab your 6-2 notes and let's start going through some of those. Hold on, I gotta print the notes for myself. Be right back. Thank you for your patience. Okay. This first thing we're not going to worry about because basically what we did yesterday. We just got to talk through it. We did it that way. So don't worry about that top part. I just, like, it's more vocabulary I'm worried about as I go through this. So that's kind of what I'm looking for. So here's a couple examples. one-sided hypothesis test means HA is P is less than, or HA is P is greater than. You're only looking in one direction. So they're called one-sided because we look at one side of our null hypothesis. A two-sided would be like, I'm worried about either direction. Then just like vocabulary, that first one is your null hypothesis. Or that other one, either one. And then the HA is your alternative hypothesis. So this would be, someone claims 70% of students here have a job after school. That's the claim, and I think it's wrong. I think it's less, so I would try to collect my sample and show that it was actually less. This would be like 20% of people take an AP class. I'm like, no, I think it's more. So I make my hypothesis based on that, and I do the math based on that. All right, next page. The null hypothesis is always P equals something. It has to be an equal sign. And actually, no matter what we do, whether it's P or mu or whatever, the null hypothesis, the claim is always this is this. Like I'm saying this is a number, this equals this number. And then the alternative is we're going to try to prove that it's bigger, smaller, or different. But the original one has to be equal. So alternative is above or below that. Just what? I'm just going to do that. The alternative is above or below that. That. Yeah. But our hypotheses are always based on our population parameter. Is the population parameter P or P hat? P. You said it and then you kept talking. Alright, two-sided. So again, this is your null. This is your alternative. Are you still talking? And this is different because this is like, I'm not sure which way. I don't know if I think it's bigger or smaller. I just think you're wrong. So you claim I'm passing 70% of my classes. I'm like, no, there's no way. You're either passing them all or none. Something like that. And then I would collect data and try to prove that. So it's different, not greater than or less than. Let's go down here. This is the definition of a p-value, or it's a definition of a p-value. That's a way to say it. Okay, the event occurring. How do I notate that? The probability that our probability that we find in our sample is the probability of the event occurring as far as we know. What do we call the probability that we find in our sample? P-hat. So now this is p-hat, that's like the sample. And then the original claim is your actual P, your population P. Okay. This is like the extreme definition of p-value. going further than I think you actually really need to, but it's okay to look at it. So the p-value is the probability that if HO is true, the p-value will be as extreme or more extreme than what we observed. I know that doesn't make any sense. Let me keep going through this whole thing, and then I'll try to explain it with pictures and other words. We compute this probability by using our sample statistic t hat. That's our sample. And our null hypothesis. We calculate z-scores. That's what we did yesterday. And then we make a decision, and that is set by a significance level, which is your alpha. I said Jesus this yesterday, everybody thought it was hilarious. Okay, so the p-value is, I'm going to write a definition I like better. The probability that our result is based on sample variance and p is actually true. So like when you take a sample, weird things happen. You can get results that are like very far away from what is expected, but sometimes that's from like just randomness. Like, oh, that just happens. And sometimes it's like, okay, that's like way too far away, and now like that's not just variance. That's both. Like that initial claim is crap. It's not just variance. So that's what the p-value helps us decide. All right, keep going. Significance level. That's our alpha for that. It's not. We're not gonna ever have to choose it. So I'll give it to you in a problem. And then these are like your two decision things. These are kind of when you do all the math, you get down to this part at the bottom, and that's like where it all comes together, and you either reject or fail to reject. So if our p-value is smaller than alpha, p-value, like I wrote it like this yesterday, the p-value is less than alpha. We say the test is statistically significant. There was a significant enough difference that I can say, yeah, that the original claim is wrong. So statistically significant. And we reject. The probability of this event occurring by chance, like from sampling variability, is so low that we say it's not sampling variability. So let me try to put that in like normal, like in an example. I'll give you a second to write. And then we would reject HO. Hobbs, what's your average? What do you swim? What's your best event? What's your average time? 109. Alright. Hobbs, this is mean. Like that's an average set of a proportion, but the concept is the same. So Hobbs says, hey, come watch me swim. I'm like, oh cool, how are you gonna do? Like what should I expect? Average time is about 1 minute and 9 seconds. So I go watch him swim and it takes him 1 minute and 10 seconds. Would I reject his claim? No. Does it prove his claim true? No. but I wouldn't be able to reject it. Now I go watch him swim, and it takes him 2 minutes and 30 seconds. So one of two things happen. Either it was just like the worst event he's ever swam in his swam in his life, and I just happened to be there that day, and it was just like a crap storm of events. Like he was sick and he didn't get any food, and blah blah blah. And it was just random variance. That's one possibility. The other possibility is that's wrong, and he lied to me. So if it's that far away, which one will we think? That it was just a bad luck, or he lied? He lied. I'm not calling you a liar, but so that's the idea. When it's so far away that like that's not just randomness. That's when you're like, okay, I'm going to reject that, and then we'd say, okay, now I think he's a liar, and I think the alternative hypothesis is true. So in that case that I just described, the p-value would be like incredibly small because his average is 109, and then 2 minutes and 10 seconds is like way over there. So the p-value would be almost zero, which is less than anything that I would give you for alpha. So we would reject because the p-value is so small. Meaning the probability that that was just randomness was very, very, very small. The opposite, if our p-value is larger, now we say the test is not statistically significant. We didn't prove anything. Then don't do it out loud because I want everyone to kind of have a chance at it. But see if you can fill in that blank. The fact that P and P out are different is due to. Don't say it. Don't say it. Don't say it. Most of the word about better at this point. Pretty much only word about better. Don't say it. You want to say it.
I don't even know what you're talking about, to be honest.
Okay, perfect. So, like in Hobbes' case, he said 109, I see 110. Those are different. But they're not different enough to reject the claim. And I'd be like, yeah, those are just different because of sampling variability. And then in this case, we would fail to reject HO. And then we've talked about this. I think this makes sense to you guys at this point, but this does not mean we accept HO. We don't. We did not prove the claim. We either reject or fail to reject. Okay. Like what?
Like you want everything that says wrong.
Well, like you would only do it if you thought they were wrong. It's not like I know what you mean. You're trying to prove people wrong all the time. Don't worry about that. That's not something I'm worried about. All right, I'm gonna do some sketches, and I think they'll make sense like after. Two-sided hypothesis test will look like this: HO, P equals whatever. HA, P does not equal whatever. So, if I sketch that, this would be like your P, your blank, whatever. Your P. Right in the middle. And then you would get, I'm going to wait until people write because I want you to like hear what I'm going to say. That one I was very disappointed in actually. I'm going to do it for a little longer. Alright, so when you do a two-sided, you're going to get a result that's only on one side. You're only going to get one result. So let's say this is 70%. and then my result comes out to 80%. So what you would do is that would be your p hat, and you would shade and be looking for that tail probability. And you would also go to the other side and do like that version of p hat. So it's not really p hat, but it's like kind of p hat. That was a pretty good explanation. Did you guys get that? It's p hat, but not but kind of. Are there any questions on that? It's mirrored p hat. That's good. So this was 0.7 in the middle, and I got 0.8. I would shade above. I would also go to 0.6. I want to be like equidistant from the middle, and I would shade the tail on that side also. So it's like approximately p hat. Kinda, yeah, same idea. So let's just do a couple other numbers to practice. If this was 0.5 in the middle, I took my sample and I'd say it's not equal. So I'm not looking specifically above or below. I'm looking for both. And this, I find 0.3 in my sample. So I'd shade on this side. And what would I do over here? 0.7 and I'd shade on that side. Does that make more sense than kind of, but not? Alright, turn the page. Wait, go back. Sorry. The p-value is the total area of those two parts. So they both count. So your p-value of a two-sided test is usually bigger because it gets double. Where the p-value of a one-sided test is just like the one. So I would add up these two areas, compare that to alpha, and see if I'm going to reject or fail. Alright, so I'll flip the page for real. One-sided test could look two ways. It could be p equals, so HO always has to be p equals, every single time. And then HA, let's say it's p greater than whatever. We have that. That's it. P goes in the middle. If I suspect that the actual answer is bigger than that, then my p hat will probably come out bigger. It'll probably be over there. And this region over here, the area of that is the p value. And then the opposite if I'm going the other direction. So if H of R has to be p equal, so if HA is p less than, I think you could probably do this yourself at this point, but let's do it. It's a carbon. So then I would have p hat over here somewhere. I would look to the left because this is less than, so I'm looking to lower values, and then the area is this p value. Are we still writing this, or can I move on? Still writing. Okay. Don't worry about this because we did that yesterday. We're doing it in a minute. I want to go through how to find the p-value in these three situations. So, if you remember back to yesterday, we found the z-score, and then we used that to find the p-value. So let's say it was a less than test. All three of these would have the same null hypothesis, right? Because it would just be equal. And then this is less than, not equal, greater than. But they'd all have the same original hypothesis. So in this case, if p is less than, I'll get a z-score that's over here. And I want to find that area. So when we find that, your p-value would equal normal CDF. Then you tell me what to what if I want to find that area? To the z, right? So it'd be negative 9999 up to z. And that would give you the p-value, which is the side, which is that shaded area. So if it's less than, you're looking at the left tail. Let's do that one next. If it's greater than, we're looking at the right tail. So you can probably figure this one out on your own, but let's go through it. So in this case, I'd have a z-score over here, and I'd be looking for that area. CDF. What to what? Z to Good. But then if we're looking either direction, so like there's my P. That's a good one. I'm proud of that one. I'll get a Z that's either over here or over there. I'll get one of them. But the p-value is the combination of those two areas. So what you've got to do is find one of those. You can find both. So I could do like normal CDF negative 999 up to Z plus normal CDF Z to 99999. But what do we know about those two sizes? No, they got to be the same. Because you're like Z away from the middle in both directions, so it's symmetric. So you could find one of them and double it. Is the like typical way to do it. So I would go like normal CDF, and you could pick either one. Yep. So that's another way. You could do 1 minus normal CDF from like negative Z to Z. But you're just trying to find these two shaded parts. I'm going to put, there's a bunch of different ways to do it. I'm just going to write one down. I'm that done. Right? What do I still need to put here? Times 2. Because that just fits this part. But the not equal to test is supposed to find both. So you would put times 2. Alright, questions? Let's try this is like the free response essay type thing. So read through that every second, and we'll try and go through that whole process. And then tomorrow we'll do a template, so you have like the kind of notes guide for it. Maya, do you have this packet? Great. I threw them away yesterday. Well, I needed one too. I had to copy myself. I'll get it. I got so excited that you had an actual stats question. And you were like, what are your plans tomorrow? I will not be here at college. I will be here at stats.
What?
You're not in college. Why are you upset? I was joking that it was the other way. I don't know yet. Probably some calc. Yeah. It'll be a work day on something. Garbage ball. Okay. So, first of all, we gotta kind of start thinking about this too, because you eventually have like 8 of these processes. And you have to choose which one. So we have to start like thinking about which questions. So first of all, what is happening? Class once a month.
Can we see what hackers have to say about this?
Okay. So our first choice is: are we dealing with means or proportions? Proportions are just percent. So are we dealing with means or proportions? We're dealing with proportions. Right there, 80%. That's proportion. Also, it literally says the word proportion. 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 So those are all pretty good clues. Second thing we're looking at, is it a test or an interval? So a test asks us to, it'll either say test, like this is clearly a Or it'll ask us to answer a yes no question. Is this statistically significant? It's a yes no question. Confidence interval would ask us to provide an estimate for something. So let's put that like on the side. Confidence interval asks you for an estimate. A test asks you a yes no question. So far we know this is a test and we're dealing with proportions. So far I can do this. It is a blank proportion. I want to title it, right? I'm missing something though. I'm missing how many proportions we have. Is it one proportion z-test, or what we're going to get into down the road is a two proportion z-test. Well, how many proportions do we have? We have 41 out of 60. That is one proportion, so this is a one proportion z-test. Alright, so to start off, I would define it, and I would say P is the true population proportion with computer at home. And then I want to set up my HO and my HA. So reading through the problem, it says Alan reads a report that says 80%. He believes the proportion is smaller than 80%. So remember your HO has to be equal. Your HO is where you put the greater than, less than, or not equal. So HO would be P equals what? 0.8. And then HA, well, he believes it's smaller. So P is less than 0.8. So this is always equal, and you get it from the problem. And then you're going to get the like greater than, less than, not equal from the problem also. Which just depends on the word. I'm going to put alpha up here also. What is alpha? Alpha is the 0.05. It's 5% significance, but we make it a decimal. So it's 0.05. And some people like to write p hat up here. You don't have to, but it's kind of like a little helpful to just see it. So it's 41 out of 60, which is not a friendly decimal. Okay, so 0.683. So the conditions. Shape, we're looking, is it approximately normal or not? And we're looking for successes and failures. Do we have at least 10 of both? So how many successes do we have? 41. How many failures? 19. I hate that like phrasing sometimes. Like, I just basically said you're a failure if you don't have a computer at home. That's not what I'm going for. It's like in terms of this question, that's considered failing. But what? There's a lot of people that don't. So anyway, your shape is approximately normal. Because I have 19 failures, 41 successes, and those are both greater than or equal to 10. The center is going to be P equals 0.8. That's what, it literally tells us right here. How do I know that? We took an SRS. SRS. And then the spread, I want to be able to use the standard deviation formula. So I want to be able to say the standard deviation is the square root of 0.8 times 0.2 over 60. And get what that is. Why am I allowed to say that? It's the 10% thing, right? So 60 is less than or equal to 10% of all U.S. high school students. So I'm going to figure out that decimal too. You guys get 0.0516. So that's like intro. That's my conditions. What comes next? The class you thought this was when you said that. Yeah, math class. So I gotta write my formula in words, which is statistic minus parameter. So that's basically saying like how far are we away from where we thought we would be. Divided by what? Standard deviation. So our statistic is labeled as p hat, our parameter is labeled as p, and our standard deviation is the square root of pq over n. Then we're going to pop our numbers in there. So our p hat is at 0.6833. P is 0.8. And what can I put on the bottom? Because I already calculated it. That's the 0.0516, right? So now let's figure that out. People in calculus, I must admit, I just had a choice to type this in my TI-89 or my 84. And I'm for sure choosing the 84. It makes you feel better. So I got a z-score of negative 2.26. Agree?
Yeah.
We're good there?
Yeah.
Are you saying that to make me feel better, or did you actually? Me too. Alright. So if I draw that out, z equals negative 2.26 is over here. And the p-value, am I going to look to the left of this z-bar, to the right, or to the right? To the left. Why? Because of this less than sign. That tells me which direction I'm going to look. So it could happen that you get a z-score way over here, and you're still looking below. Like if your hypothesis was awful, you might think things are lower, but it actually comes out higher. It could happen where your z-score is over here, but it's a less than, so you shade the whole thing. It's rare, but that could happen. So that area is your p-value, which you're going to find by doing normal CDF. Negative 99999, comma negative 2.26. Let's find out what that is. So I got 0.0119. Well, our alpha was what? 0.05. So are we bigger or smaller? Smaller. So what this tells us is this was so unlikely that it's not due to random chance. It's so unlikely that there's just no way this is right. It's very, very, very unlikely that this is right. So we're going to reject HO because we are very far away from the middle. There's only like a 1% chance that this is due to random variation. And this tells us if it's less than a 5% chance that it's due to random variation, you should reject. So we're going to reject. So let's phrase that. So since p-value is less than alpha, we reject HO. And then I'm going to say the test is or is not statistically significant. Which one is it? It is. If you reject, significant means like I found a significant enough difference between what we thought we'd get and what we actually got. That's a very significant difference. So this is both. So it's got to be a significant means like big, right? So if it's a big difference, that's when you reject. So this means we reject HO. The test is statistically significant. So I always make a statement about HO. I rejected it. make a statement whether it's statistically significant or not. And then I make a statement about HA. So if I rejected HO, what does that mean my thoughts are on HA? I think it's good, right? If I said this one's bad, I must be doing it because I think this one's good. So I'm going to say that. So we think HA is likely correct. So kind of your process here is you go HO, significant, HA. Like there's three sentences. What about HO? What about whether it's significant or not? And what about HA? And I'll put that in the template too. We'll do that probably tomorrow. Questions I can answer? Anything? Is it getting like more clear than it was yesterday? What we're after? Maybe. Give me thumbs up or down how you felt after yesterday. After yesterday. Okay, now today. Okay, fair enough. I have assigned some con. You can start that in the next 10 minutes if you want or not. It's up to you. Tomorrow I think we'll do a template and then probably give you